Today we're going to take a look at the most overlooked yet effective tool against cancer. It's true that cancer is a very dangerous disease. It's the second biggest killer in the world. But scientific literature, especially over the last 2 decades, has shown us how effective this tool is against the disease. As information generally takes 1 to 3 decades to go from research into medical guidelines, this tool has not yet made it into sweeping recommendation. But in today's video, I'll put you on the leading edge of science. Now, my name is Merlin, and my dad was diagnosed with a very aggressive cancer about 3.5 years ago, but he's still alive. My brother and I founded Marchwood to teach the exact things that we did to help our dad live longer and become cancer-free. And as of 2 months ago, a friend of a friend has used our mosaic method to increase his life expectancy by 3.5 years and more. But don't just trust our stories, do verify yourself. To make this easy on you, we've put together a document which lists all of the scientific resources that our methods are based on so that you can verify it for yourself. You can find this resource called the Mosaic Method Guide at marchwood.com/mosaic. For the executable part of this video to make sense, we need to pick apart a misconception about cancer that is so common that it's taught in every medical and biological course today. Cancer has long been viewed in the scientific establishment as a genetic disease, meaning a disease caused by accumulating genetic mutations. The problem with this view is as obvious as it is overlooked. If this understanding of cancer were truly correct, we'd be much better at preventing it and treating it. Yet we aren't. Why is that? Now, this might sound insane, but cancer just isn't caused by genetic mutations. Whilst genetic mutations are present in cancers, they are not a driver of cancer development, but a result of cancer development. This is a very, very tough pill to swallow, so let me prove it to you. The genome of a cell is contained in a structure known as the cell nucleus. So if cancer was truly a genetic disease, the transfer of a nucleus from a cancer cell into a healthy cell would lead to a cancerous cell. The thing is that this just doesn't happen. When we transfer a cancerous nucleus, so a nucleus from a cancerous cell into a healthy cell, the resultant cell does one of 2 things. Either it will stop behaving like a cancer cell and have no cancerous characteristics whatsoever, or it will go into apoptosis, a type of cell suicide. This holds true for more complex life as well. For example, in an experiment where researchers transferred the nucleus, so the genetic information, from a frog tumor into a healthy frog egg cell, the resultant embryo developed normally into a tadpole. Both of these experimental results would be absolutely and utterly impossible if cancer were truly a genetic disease. Now, if you want to double check these claims, you can just get the Mosaic Method Guide for free, where we list all the scientific evidence for our claims and where you can double check them. You can get it at marchwood.com/mosaic. But if not genetic mutations, what then causes cancer to develop? If we look at a cell, it has primarily 2 parts to it. It has the cell nucleus, which of course holds the genome, and it has the cytosol, which holds the entire rest of the cell, but most importantly to us and to cancer, the mitochondria. Now, mitochondria are most known for their role in energy production, but mitochondria are also the primary quality control units of our cell. When they are healthy, they are able to independently initiate apoptosis. And if you remember, apoptosis is a type of cell suicide. Now, from experiments, we know that if we transfer a healthy genome, so a healthy nucleus, into a cancerous cytosol without the cancerous nucleus, we get a cancer cell. We also know that cancer cells exhibit highly modified metabolisms. We know that cancer cells have fragmented and dysfunctional mitochondria and thus no ability to initiate apoptosis. And we know that pharmacologically forcing a normalization of mitochondrial function in cancer cells leads to a higher rate of cell suicide. And these points of fact allow us to infer that cancer isn't caused by a cancerous nucleus, but by a cancerous and dysfunctional cytosol, especially by dysfunctional mitochondria. As mitochondria are heavily involved in energy metabolism, this now opens up a new avenue of attack against cancer. If we can modify our body-wide metabolism to stimulate mitochondrial activation, and if we thus can actually reactivate these dysfunctional mitochondria, we can stop cancer by getting cancer cells to kill themselves. There are primarily two kinds of energy metabolism within our cells: aerobic and anaerobic. Aerobic energy metabolism is very fuel and waste efficient but requires oxygen to function. And anaerobic is very inefficient but does not require oxygen to function. All cells will switch from aerobic to anaerobic metabolism if there isn't enough oxygen available. But growing cancer cells will use anaerobic energy production even when sufficient oxygen is available. This is where we get back to mitochondria and their involvement in energy metabolism, because aerobic energy metabolism only happens in the mitochondria. This means that if we can promote or even enforce aerobic energy metabolism, we can promote the normalization of mitochondria and thus promote cancer cell suicide. Our cells are able to use a variety of fuels to produce energy, but only one of these fuels can be used for anaerobic energy production in the cytosol. And this fuel is glucose, which is just a simple sugar. Now, our liver produces glucose normally to maintain a stable and healthy blood sugar level. So we cannot fully eliminate this glucose, but what we can do is eliminate blood sugar elevation. And this is where we get into the executable part of this video. It's rather self-evident how we can stop blood sugar elevation. We need to stop eating those things that have the ability to elevate blood sugar. All foods which contain sugars and or carbs elevate the blood sugar. This is because sugar is directly absorbed from the intestines into the blood, and carbohydrates are digested into sugar before also being directly absorbed from the gut into the blood. This means that when talking about diet and cancer, there are no good and bad carbs. There are only blood sugar elevating carbs, and this blood sugar elevation makes them bad carbs. Since carbohydrates are the primary energy source for most people, abstaining from carbohydrates in an effort to fight cancer will leave us energy impoverished. This now means that we need to correct for this by supplying the body with fuels that can only be used in the mitochondria. And there exists such a magical fuel source, and it's called fat. As fat can't be used for anaerobic energy production in the cytosol, the switching out of carbohydrates with fat in the diet necessarily stimulates mitochondrial energy metabolism. Now, fat is way more energy dense than carbs, but it might still be surprising just how much fat you need to eat to replace the carbs that you've abstained from. For example, to counterbalance a kilogram of potatoes, you need about 150 grams of butter. And to counterbalance a kilogram of bread, you need 360 grams of butter. Now, this will feel like a lot, but your body does need the energy. Now, the easiest way to ascertain whether you are eating enough fat is just to check whether you are in ketosis. Ketosis is a metabolic state where you burn fat and produce ketones. That's where the name comes from. And you can test whether you are in ketosis by buying a very, very cheap breathalyzer on Amazon or wherever that analyzes your breath acetone level as a proxy of your level of ketosis. Keep in mind that this is just a tiny, tiny part of the Mosaic method, and then doing this alone will give you perhaps a leg up on cancer, but it's nowhere near enough to cure it. So if you want help with implementing the entire Mosaic method, you can get in touch with us and join us in our war on cancer at marchwood.com/outlive. Now, before we wrap up the video, of course, I want to give you a small bonus because this wouldn't be a Marchwood video without it. We have now promoted aerobic energy metabolism by switching out carbs for a fuel which is only metabolizable by the mitochondria, meaning fat. But there's more we can do. If you cast your mind back to the very characteristic of aerobic energy metabolism, it was that aerobic energy metabolism needs oxygen to function. It thus doesn't matter how much fat you supply to your body if you don't have enough oxygen. Thus, if we want to promote aerobic energy metabolism, we need to make sure that oxygen is delivered purposefully and efficiently into our tissues. This will sound insane, but we can improve oxygen delivery into our tissues by breathing less. No, I didn't misspeak. Yes, I'm serious. Yes, that sounds stupid. Let me explain. Oxygen delivery to our tissues depends on two things. One factor, of course, is how much oxygen is bound in the blood. The other factor is how tightly is it bound to the blood. Now, self-explanatorily, It doesn't matter how much oxygen you have in your blood if it's too tightly bound and cannot exit the blood and enter the tissues. Now, luckily, having too little oxygen in our blood is almost never the case for healthy humans. If you have sleep apnea or lung damage, this might be more of a concern, but if you are a generally healthy person, this isn't a concern. For most of us, the most important part about oxygen delivery is the tightness of binding of oxygen to the blood. Now, this tightness of binding is known as binding affinity, and it's the binding affinity between oxygen and hemoglobin, which is a protein in our red blood cells. And this binding affinity is heavily impacted by the presence or absence of carbon dioxide. The more carbon dioxide is present, the lower the binding affinity, meaning the better the ability of the blood to give oxygen to tissues. But what has this got to do with breathing less? Our lungs are incredibly good at ingesting oxygen and expelling carbon dioxide. And they're so good at this that it's a problem in patients who hyperventilate. Because patients who hyperventilate will expel so much CO2 that the binding affinity of hemoglobin to oxygen in their blood will increase so much so that they risk internal suffocation. And the fix for this is very, very simple. You give the patient a plastic bag over their mouth so that they rebreathe their exhaled air. This rebreathing improves carbon dioxide retention and normalizes oxygen delivery, thus staving off internal suffocation. Now, for cancer patients, this means to just breathe as little as possible whilst still maintaining a healthy oxygen saturation in the blood. The easiest way to do this is just to simply always breathe through the nose, because the nose limits the speed at which you can breathe. And this applies even to strenuous exercise. I've done this when engaged in high intensity wrestling, and I can tell you it's absolutely miserable. Interestingly though, it significantly improved my endurance and my strength and decreased my feelings of fatigue. So even though it was miserable, it was exceedingly beneficial to my performance. Now, in cancer, the same improvement of oxygen delivery can help us promote aerobic energy metabolism. And again, the promotion of aerobic energy metabolism will necessitate an activation of mitochondria. This in turn can help normalize mitochondrial function, which in turn can kill or heal cancer cells. That was a lot, wasn't it? So let's recapitulate. Firstly, cancer isn't a genetic disease. Instead, it is a disease of the cytosol and more specifically of the mitochondria. Secondly, normalizing mitochondrial function leads to increased cancer cell suicide rates. And we can promote this normalization of mitochondrial metabolism by promoting aerobic energy metabolism. And we can promote aerobic energy metabolism by improving oxygen delivery to the tissues and by providing fuels which can only be used in aerobic and not in anaerobic energy metabolism. And lastly, of course, we can improve this oxygen delivery simply by breathing less, as insane as that sounds. This means that from this video, you can take two things away that you can start doing right now. You can exchange all your carbohydrates for fat in your diet, thus promoting aerobic energy metabolism by exchanging fuels. And then you can start breathing less. This is going to take practice, but you can start doing this today. And this is going to improve oxygen delivery and thus promote aerobic energy metabolism, not by fuel, but by oxygen delivery. If this has been interesting or helpful to you, or both, then don't hesitate to annoy your friends and family with it. Share it, like it, subscribe, and of course, do comment whatever questions you do have. I'd be glad to answer them. Now, if you want to double check our science or want to join our war on cancer, you can find the links in the description below. With all that said, I wish you the very best. I wish you swift healing, lasting health. May God bless you and your family.